Good day, learners. We are on video number 3 of vertical projectile motion. That is, we are sketching the position time graph, the velocity time graph, and the acceleration time graph. Okay, so remember that we have the definitions, that is the projectile, an object which has been given an initial velocity and then it moves under the influence of gravitational force only. Then we have another definition, that is a free fall, the motion during which the only force acting on an object is the gravitational force. Okay, now the object is thrown vertically downwards by 10 meters per second. So we are going to draw the graph. Remember, the graphs that we are going to draw is a position versus time. Okay, then it's a velocity versus time, then is acceleration versus time, which means if we are drawing the position time graph, we will need the position of a ball at a certain height, right? Then we will also need the time. The starting time is always 0 and the ending time will need that ending time. Okay, let's start with the position. In this position, this ball is 50 meters above the ground. 50 meters above the ground, right? At this position. Then at the ground, the ball is in 0 meters. Okay, so the height is decreasing up to 0. Okay, now we need the time here and the time here, so that we will draw the position time graph, right? Then if we are about to draw the velocity time graph, we will need the velocity here, that is 10 meters per second, and the velocity here. Hoping that it is clear. Now let's look at the time from the top to the ground. So we are going to use the equation of motion to calculate the time. Let's collect the data. So we have, what we have here is the initial velocity. The initial velocity is 10 meters per second, but downwards, right? Then we have the height. In this case, the height is dy, which is 50 meters and is below the starting point, which means downwards. All right, then we also have the acceleration, which is 9,8 meters per square second downwards, right? Then we are looking for delta t. So we have 1, 2, 3, 4 on the data, which means you can choose the formula. Now take down, since everything is directed down, so let's take down as positive. Downwards must be positive, meaning that this one is down positive, this one is down positive, this one is down positive, right? Now the formula that we are going to use here is third one, that is dy is equal to initial velocity times time plus 1/2 acceleration times delta t squared. So we have delta t, here is delta t, acceleration, here is acceleration, dy here is dy, initial velocity here is initial velocity. Now let's substitute. Everything is positive, so we have 50 meters, which is equal to the initial velocity is 10, delta t is what we are looking for, plus 1/2, a is 9,8 delta t squared, right? Now we press calculator. So this one is still 50, then we have 10t, then here we get 4,9 delta t squared. Then we transpose this one, then we arrange this one to a standard form. So this one is squared, which means that is our first term of quadratic equation, that is delta t squared. This one has t to the power 1, second term, that is then delta t. This one, when you transpose it, there is a sign negative, then it's negative 50 now. Now we need to factorize here. The easiest way is to use the quadratic equation. So the quadratic equation says x is equal to minus b plus or minus of square root of b squared minus 4ac. Everything is divided by 2a. So in this case we have t, so we are solving t. So t is equal to minus b plus or minus square root of b squared minus 4ac. Everything is divided by 2a. A is the coefficient of first term, b is the coefficient of the second term, then c is the constant. So we have the first term, the coefficient is a, so this is a, then this is the second term, the coefficient is b, this is our b with this sign, then this is the constant, this is c is negative 50. Now we can substitute. In place of b, we are going to substitute by b, which is 10. So we have 10. Let's write one sign here, choose one sign. So b is 10, then 10 squared minus 4 times a is 4,9 times c is minus 50. Right? Then everything is divided by 2a. 2 times a is 4,9. Now we press calculator, then we get t. So t will be equal to, so we change sign here, then we put minus because we have plus or minus here, then we press calculator, then another t will be equal to minus 4,37, but the time can never be negative, which means this is not the time we're looking for, right? Then this is t at the ground, so we have t at the ground, so the time here is the starting point is 0 seconds, then the time here is 2,33 seconds, right? So we can draw the graph, the position time graph now. Okay, the position time graph, position time graph. Remember on the second video we said position time graph is a curve-like graph, is a parabolic graph, which means you cannot draw the linear graph here, which means in this case it will be just like this, it will bend like that, then this is the ground, and remember the ground is our 0, in this case is in 0 meters, which means when you draw the graph, your graph will end at 0. Okay, so this is 0, this is time, that is x in second, then y is position, so our y is delta y in meters. You can just write position in meters. Okay, then here we have the maximum height, in fact the height of the ball starting point, that is 50. So it's 50 meters. Already write the meters. Then you just copy this line. This is our 0 part, which means you draw the line up to here. Then you're done. That is the position time graph. That is the position time graph. Then you write the time here. The time is 2,33 seconds. Then you are done. That is the position time graph. Okay. Then let's go to the velocity time graph. When we draw the velocity time graph, we need velocities and time. So we know that here the time is 0 seconds, that is the starting point. Then the time here is 2,33, right? We need the velocities. Now we know the velocity here is 10, which means we need the velocity here, right? Now let's collect the data and calculate the velocity. So we have the initial velocity, which is 10 downwards. We have delta y, which is 50 and is below the starting point, which means downwards, right? Then we have the acceleration, which is 9,8, always downwards. Then we are looking for the final velocity. Final velocity is what we are looking for. Then the formula that we are going to use is this one, plus 2a delta y. So the final velocity is required. The initial velocity is, now we have to choose the direction. We set it down as positive, which means this one is positive, this one is positive, this one is positive, right? So the initial velocity is positive 10 plus 2 times acceleration 9,8 times delta y, it's 50. Then the final velocity square will be equal to 1080, then square root both sides. Remember there is that plus or minus here, so the final velocity square will be the positive, or square root. Therefore the final velocity will be the positive 1, which is equal to 32,86 meters per second. Okay, it is positive because we set down as positive, so that is downwards. Now we have the velocity here, which is 32,86 meters per second, which means you can draw the graph, the velocity time graph. Now when you draw the velocity time graph, just have the coordinates to make things easier. But in position time graph, there is no need for the coordinates. You just need the height and the time. Then you draw the graph like this. Okay, then that is the position. But the velocity time graph is a straight line graph. It's a straight line graph. Y is equal to mx plus c. So let's just have the coordinates to make things easier. So this is the first point, right? So let me draw the Cartesian pair. Since it is a velocity time graph, on the y we have the velocity in meters per second. That is velocity time graph. Okay, so we have the velocity there. Then here on the x-axis we have delta t in seconds, which means their coordinates is x, that is delta t, y, that is velocity. So the first point, on the first point, that is starting point, the time was 0 there, then the velocity is 10. Then on the second point, that is the last point, the time there is 2,33, whereas the velocity is 32,86. So these are the coordinates that we have. So we are going to plot them, and remember, this is a linear function. Okay, let me draw the bigger one here. So we have the y-axis and the x-axis, so it's 0 here. So this is the velocity in meters per second. Then this is the time in second. So we have, let's start with x. X, we have 0 and 2. So we have 2 here, 2,33. 0 is there already. Then on the y we have 10. So we can have 10 here. Okay, let me just write here. Sorry. Now we have 10 here. Then we have, sorry for that, trying to make it neat. So here we have 32,86. Don't forget V, meters per second. Now let's start with the first point. This is the first point. X is 0, x is 0, that is 0. 0 is always here. Then y is 10. So this is our first point. Then the second point, x is 2,3, x is 2,3, y is 32,86. 32,86. This is the point number 2. Then you join, that is a linear function. Then we are done. Okay, that is the velocity time graph. Now that the velocity time graph goes up, which means down was positive, downwards was taken as positive since it is increasing. But when the graph is decreasing, down was negative, up was positive, just like that. Okay, down now is positive. Let's go to acceleration time graph, which is very easy. So the acceleration time graph is not a big deal because acceleration is constant. So what is important is to know which direction was taken as positive and which one was taken as negative. Remember, we have 2,33 here. So we said take down as positive, which means the acceleration will be positive. Then we are done. Then here with acceleration in meters per square second, then here we have delta t in second. Thank you very much. Don't forget to subscribe on the video for the other videos, so that you will see the new videos on the channel. Also comment, you can suggest what things that need to be changed, what I can add, what can correct here. I want to make this channel to be successfully. Thank you very much.